Saxon Algebra 1, Lesson 58. We're returning to our old friends, the percent word problems, which are frickin' formula babies. Let me review to you exactly what we're talking about. Sometimes we use a fraction form of these problems. A fraction times a group of numbers will give you a special group. For example, let's say you have 20 peanut M&Ms. I just ate some peanut M&Ms. I don't think I had 20. I think I had more like 11. But in this group, we've got 20. If we want to divide this, right now we have a group of 20, all right? Those are the actual M&Ms. I'm drawing a picture of them. Let's say that we want to say that I get to eat 5 of them. So I get to eat this whole row. That means I'm dividing the original 20 into 2 groups. The 5 that I get to eat and the 15 that are left for, I don't know, the neighbors when they come over. This number we call the of number. This was the total group. It's what we started with. This is called the is number. It's the special group. It's the part that belongs to me, right? We could also make up a problem about when the neighbors came over and we could make this the special group. But in each problem, we only get to have one special group, but sometimes we use the other information in a helpful way. Now, if it's a fraction, this always represents 1. And then we have to represent our special groups in terms of fractions. This would be 1/4, right? 5 is 1/4 of 20. And this would be 3/4 of 20. So whenever we take a number and we divide it up, we identify the total group and the special group. We identify the number in each of the groups, and then we identify it with a fraction, or we can do it with a decimal, right? If we wanted to be decimals, this would be 0.25, and this would be 0.75, or we can do it with percents. Oh, this should be is, not 18, okay? And because the world loves percents, we often use the percents. We do a lot of problems in those just because that's very common in our world, all right? This has turned into a very messy little diagram because I tried to put all 3 of these in one on there. But I want you to see that we're saying the same thing in 3 different languages, the languages of fractions, decimals, and percents. Now, specifically related to percents, we usually use this style. This is when the percent is less than 100. And we end up with a picture just like the one that I drew, where we divide it. And I fancy that this is what I call an ice cream sundae style. Because to me, this divided group, I imagine hot fudge, and I imagine it in a nice little dish. Maybe a little glass sundae dish. Maybe a cute little spoon over on the side, right? So to me, I imagine that this type of drawing looks like an ice cream sundae. Now, let's compare that to percentages where our ending result is greater than 100. And I'm going to squish that down here. In these, our group is not divided. Our group grows. What? And these can be seen as a peanut style. You know how peanuts in their shells have that bump? That's what I think of, because our group, our original group, has gotten bigger. So it's kind of grown that extra bump, right? So I call these peanut styles. And in these, we don't have 2 special groups. We just have 1 special group. It's the extended, all right? This kind can also be seen as the baby Jesus style, because as one of my students pointed out to me, It kind of looks like a little sleeping baby Jesus in his swaddling clothes. And I dig that. I think that's really fun. So there he is, okay? It can be either way. But both of these styles represent baby Jesus. It represents taking an original group and growing it, all right? So we're gonna practice both kinds of these problems in this lesson. Let me look and see. Oh, my pages are stuck together. Yeah, we're gonna practice both the hot fudge sundae style and the peanut toddler baby Jesus style. Okay, ready? So this is all just information to help you get back on that part of your brain. And I think we're doing 3 problems. Let me check. 1, 2, 3. Again, my favorite number. Example 58.1. A diagram should always be drawn as the first step. Thank you, John. My thoughts exactly. He even says it in bold print. Let me show you. A diagram should always be drawn as the first step. John draws his slightly different than mine. His loss. Okay, Kathy, John, and Susie have only 20 chickens left. If they began with 80 chickens, what percent of the original flock remains? Now, what I can tell you about these is sometimes it helps to think of our circles as a before and after. I guess I tipped my hand that this is going to be ice cream sundae. All right, but listen to this. They only have 20 chickens left, but they began with 80. They began with 80, but they only have 20 left. Something happened, we can deduce, to 60 chickens. Whoa, it's not good. What percent of the original flock remains? So these are the ones that are left, and these are the ones that are gone, right? So we know that this is 100%. It always is. We want to know what percent this is. Remember, this is always the of number, and the one that we're interested in is the is number. Usually it's the top, but later we're going to get some tricky ones where John will send us off in a different direction. But we're interested in what's the percentage of the original flock that remains. Okay? These are the ones that remain. Okay, so we use our formula. Percent over 100 times of equals is. All right? The percent we don't know. John likes to do this. What percent times the original group, I'm going to put that over a 1, equals the ones that are left, 20. And I'm going to put that over a 1. Now, I've run into so many students who still struggle on how to solve these because it is confusing, because depending on whether John can put the mystery here, here, or here, right? There's 3 different mysteries. He can give us 2 of the 3 and then leave us to figure out the 3rd, but he can make it any one of those 3. So this much of the problem looks the same, but the way we actually attack the algebra shifts from problem to problem. So let me remind you, first let me say this. If you are one of my students who struggle with this, it's okay. But what I want you to do right now is try, I know it's hard, try to wipe away all of your history with this problem, and let's approach it as if it was the very first time. All right? And let me walk you through it. What we do is we look for the letters. We want to end up with the letters by themselves, right? That's how we always solve equations. We want to shove all the numbers to the other side and then keep the letters on one side by themselves. So we have to get rid of this 80 and this 100. The 1's not really a problem. That'll go away. But we want to get rid of these guys. Now, we're multiplying so we could start dividing, and we're dividing so we can start multiplying, but that makes a big mess. We don't want to make a big mess. So what we want to do right here is we want to create a fraction that will cancel these numbers out. Here's the fraction I'm going to create. Here I have an 80 in the numerator. I want that to go away. So I'm going to write 80 in the denominator. And in just a minute, I will cancel those. At the same time, I've got 100 in the denominator, and I want to cancel that out too. So I'm going to write 100 up here. Do you see what I've done? I've created a new fraction. I'm going to put it in parentheses because it's new. I've created a new fraction that will make both of these numbers go away. And I did it by simply looking at who's in the numerator. Okay, fine, I'm going to put you in the denominator. Who's in the denominator? Fine, I'm going to put you up top. That allows me to cancel this against this, right? Because we can always cancel top to bottom as long as we're multiplying. This to this. Now, everything's canceled. That's how we choose that fraction, is by looking at what's here and how we want it to cancel. Beautiful. Now, however, whatever we came up with here, we have to do the same over here. And that's fine. Remember, we don't care about this one because we can just ignore that. Okay? So now we bring it over here, and this we're going to have to solve. We're going to have to cancel again over here, right? Because this and that have to be the same. This is all gone now. We get what percentage equals. Now let's cancel here. 20 into 80 goes 4 times. 4 into 100 goes 25 times. So our percentage is 25%. These chickens represent 25% of the original flock. And by simple math, we can see, oh, look, that must be 75. And by simple math, I mean just adding or subtracting, whatever it takes. This is 100%. I already wrote that down there. All right. This is the calculation that I think is messing up a lot of my students, is they just get confused about what's happening here, because I do throw the numbers around fast. All right, so this is our final answer, and we always take it back and complete our diagram. Always. John doesn't always. He is in these problems, but you always make sure that every section of the diagram has a number and then a percent or a fraction or a decimal if we're doing that style. We're mostly going to do percentages from now on. All right, let's do another one. Because if 1 was fun, 2 is wahoo. 58.2. Mimi and Jim have 75 thingamabobs. I swear that's what it says. They want to give Hal 20% of them. How many thingamabobs do they give to Hal? All right. Well, here's a pile of their thingamabobs, right? And what they want to do is they want to split their thingamabobs up. Kind of like whoever owned the M&Ms in the first problem, right? They gave me 5. So they want to give these to Hal. And then I assume they'll keep these themselves. These are their thingamabobs. I really hate to write all that out. Thingamabobs. This is 100%. This is what they're starting with. Okay, they have 75. And what they want to give to Hal is 20%. Now the percents always go on the outside, and the actual number goes on the inside. That's the way I want you to draw these diagrams. So this we know is 80%. They'll be keeping that. This is the number we want to find, isn't it? We're not trying to find the percent that they keep. We're trying to find the percent that they want to give to Hal. So, frickin' formula. This is our is group, or the special group. We're not that interested in that group. We could find that number out in a couple different ways, but we're really interested in this number. This is our of. Of is always what we're starting with. It's the total group, right? So here's what we've got. We know that we want 20%. We just write the 20 over 100 times our original group. Then I'm going to put that over a 1 equals the number we give to Hal, x. Okay? So in this case, we had the percent and we had our total group, and we were just trying to figure out the number. that is in the special group. This kind is much easier because you'll notice our letter's already by itself. John likes to use what number a lot for his variable. That's fine. If you like that better, I go back and forth to tell you the truth. It doesn't matter, but whichever letters you choose, they're over here on the right, and all of our calculation is over here on the left. Oh, that makes it so much easier, doesn't it? Well, shall we simplify these numbers? We don't have to multiply anything. We don't have to do any work to get all the numbers on one side. They're already there. So now all we have to do is cancel. I really want to do that. 3 and 4. 4 goes into 20 5 times. Now there's nothing left on the bottom, so we know that x equals 15 thingamabobs. That's my abbreviation. So this means they're going to give Hal 15. Now, I could multiply 75 times 80% to find out how many we're keeping, but I can also just subtract. It's 60. This is how many they're going to give to Hal. Thingamabobs. That's my abbreviation. I better put dots there. All right? So, again, this is to remind you that John can plant the mystery anywhere in the story, and we have to be ready to do the algebra no matter which way he sets it up. Okay, ready for one more? I promised you that we would have one where the percent was greater than 100. I'm about to follow through. Ready? Example 58.3. Bo and Christy hide 600 raisins. Okay, this is weird. This is 60% more than they hid last month. How many raisins did they hide last month? Now, this was one of those rainy day games that my mom used to play with us when we were little kids. Usually it was buttons. She would take buttons and hide them all around the house, and then I'm sure she would keep track of how many she didn't, and then we would have to go search them all out. Occasionally we did it with raisins, but the game never worked as well because we would eat them before she could count how many we found, so we never knew if we found them all. But she never hid anywhere near 600 raisins around our house. I promise you that. That seems a little excessive. But what we've got is that Bo and Christy hid a certain number of raisins one month, and then the next month they hid more. Okay, so there is our peanut style / baby Jesus style problem. Their original group has grown. Okay, so let's go again. They hide 600 raisins. This is 60% more than they hid last month. Okay, so this is last month. And this is now. Last month is always 100%. And then this is going to be some other percent that's more than 100. The 600 that they're hiding, we're supposed to assume are now. It's kind of hard to read into these problems sometimes. All right. It's 60% more than they hid last month. So the percentage is the 100 from last month plus the 60% increase means the new number is 160%. Ooh, you have to be careful about that. This is the more or the increase. Those are words that tip you off that it has to be added to 160. All right, we draw the diagram. We know that this is the of. We know that one of the joyous things about the baby Jesus style is that there are not multiple is groups, there's just one. We want to find out how many they hid last month, so that's right there. So we write 160 over 100. Here's my formula. 160 over 100 times the original number. Oh, we don't know what that is. I'll put a big X there. I'm going to put it over 1. I don't want a floater. Equals the is group, which is 600. Okay, now once again, our letter is commingled with some numbers. So we look carefully at how we want things to cancel. Here's the number I'm going to create. I want this 160 to be canceled out, so I'm going to write it on the bottom. And I want this 100 to be canceled out, so I'm going to write that on the top. I look carefully and see if this new thing I've created is going to do what I want it to do. It's going to cancel that, and it's going to cancel that. The only number I'll have left is the 1, and I can ignore a 1 in the denominator any day of the week. So this worked. This is beautiful. However, I have to do the same thing over here, don't I? I'll put that over a 1. Okay, beautiful. Now I need to reduce this. Well, the first thing I'm going to do is say, let's divide both of those numbers by 10. 16 and 60. Do you suppose there's a number that goes into that? This doesn't seem to be, I could do 30 and 8, right? I could make them both even numbers. I could do 15 and 4, and then I could do 4 into 100 goes 25 times. Do you see how I'm just canceling as best I can? And then I can multiply 25 times this. Whoops. Just a second, I'm not lining my numbers up right. I will tell you that's the right answer. So, the number that we had last month was 375. And we now have 600. There we go. That's a quickie review. Well, I hope it wasn't too quick. But frickin' formula problems are in our life to stay, so please reach out to me if they're still annoying you. Thank you. Goodbye.